Alright, Mr. Dowling again for video number 4. This is the last pre-video before we go into actual examples. I'm going to be focusing on trig. Hopefully all of you watched this just to refresh your memory. So I've already color-coded things. It's called planning ahead. I did it this time. What is trig? Well, trig stands for trigonometry, and it is the study of vectors and angles and all that good stuff. One of the most basic things about trigonometry that you'll be using so many times in this class is SOHCAHTOA, or I don't even know how to spell this half the time, so I just remember it as Oscar has a heap o apples, or of if you want. And then I just remember that they're in the order of sine, cosine, and tangent. But every one of these represents an actual mathematical quantity. So we need to make sure we actually understand that. Every single time we're going to talk about it today, these are all triangles. They're all right angles. And I'm going to explain each one. I'm going to use this part as my angle right there. That's my angle. This is where I'm originating all of my statements from. You'll understand that in a second. Because on sine, which I've labeled in red so we can all see and keep it track, sine is OH. O stands for opposite. Now, if this is my angle of origin here, which one's the opposite? Oh, I think it's this one. It's the one on the other side. That's why it's called opposite. And then it has H. H stands for hypotenuse. And if you don't know what that word means yet, it is the longest line in a triangle, and it is the one that is opposite of the 90-degree line, or angle. So therefore, this is my hypotenuse. So what about this third one? Well, this is called the adjacent area because it is adjacent to the angle and it is not the hypotenuse. Well, let's just focus on sine now. Sine stands for, or has the part OH, opposite, adjacent. If you want to write this out mathematically, it's sine theta, remember that theta from the degree to talk, is equal to opposite over hypotenuse. So if I were to stick some values in here, I could actually find out what it is. Let's say the opposite was 3 and the hypotenuse was, let's say, unknown, and I had an angle of 30 degrees. So I'm going to write this out so we can try it out. Sine 30, I said at a 30-degree angle, is equal to, well, I know my opposite is 3 and my hypotenuse is unknown. So I need to rearrange this equation. I multiply both sides by h, cancel out. But I still don't have h alone. I need to get this whole sine 30 out of here. So I'm going to divide both sides by sine 30. That goes away. So I end up with h is equal to 3 over sine 30 degrees. And you're like, but I don't know what sine of 30 degrees is. And that's why I said for your syllabus, you should have a calculator. Or at least one of my class sets. So let's actually try and calculate this out. 3 divided by 30 degrees, or the sine of 30 degrees. Now, sine of 30 degrees is actually 0.5, so it can work out very easily if you want to. And I would get hypotenuse of 6. There we go. My hypotenuse is 6. Yay. This is awesome. So this is how you find sine. Now let's move on to cosine. I'm going to need to erase this, so if you need to write it down, pause and do that. Not enough space. Alright, now let's go on to cosine. Cosine has the AH, so that means that it's cosine theta equals adjacent over hypotenuse. If we were to do this calculation again, we would find out some different values, so let's just run through it again. I'm going to take the cosine. This time I'm going to know the hypotenuse. We just found it. It was 6, so let's just try this again, see if we can get the adjacent. So cosine of 30 degrees equals adjacent, I don't know what it is, over that 6 hypotenuse I had. Well, I need to rearrange the equation again, multiply both sides by 6. This one's nice and easy because once this cancels, the unknown is alone. The unknown needs to be alone on one side of the equal sign to work. So I just take cosine of 30. So you punch in your calculator, cosine 30. This one is not as smooth. It's not just 0.5. It's like 0.866025404. But we can leave it in the calculator. Then we multiply that by 6. And we end up with adjacent is equal to 5.196 and several other numbers. Then you would need to follow sig figs to get this to be the right answer. But this is basically how you find cosine. All right, if you need to copy that down, do so. I'm erasing. Now on to tangent. Tangent is the special one. I like to think of him as special and super powerful because he doesn't even need hypotenuse to work. No, tangent doesn't care about the hypotenuse. He only cares about what is opposite and what is adjacent. So it only cares about those things that are not the fancy sounding word. I'm going to rewrite my A there. If we were to do this calculation again, same thing, you just input your values. If you don't, this time if I don't know theta, you have to do what's called an inverse tangent, and it may occur. So let me just show you through this. I'm going to choose two different numbers for my A and O just to make things simpler. Tangent theta, which I don't know, is going to be equal to, let's go with 3 over 6. And you probably can see why I chose that, because it reduces very easily to a half. Well, here's the thing though, I've got tangent theta, and I need to move the tangent over, but I don't know how to move a tangent over. On your calculator, there is a function that looks like this. To the negative 1 means this. See, any value to the negative 1 puts it in the denominator. What happens when I move the tangent over? Well, I have to divide both sides by tangent, right? This cancels, and then I divide by tangent. Or another way to write it would be 3/6, or 1/2 if you want to reduce it already, times tangent inverse. And this is what you'll see on your calculator. You may have to look around for it. It's usually right above the tangent button. You would have to probably press like the second button or the shift button or whatever you have. But first you would just say 3 divided by 6, and then you would multiply that by the inverse tangent, or take the inverse tangent of it, and you would get, sorry, not tangent, let me erase that. You would get theta, because that's what we're looking for, because this is theta equals 26.565, and you would need to use your sig figs to find out exactly how many. So you should be fine. This is how you do trig. It's one of the more complex parts, but these are the steps you're just going to be going over and over and over again. So if you need to review this video, please do, but this is the basic information to keep.